Hey you guys, welcome back. Today we're going to talk about the settlement of saturated clay. A normally consolidated clay layer has a liquid limit of 45. The effective stress at the midpoint of the layer is 2,000 pounds per square feet. Estimate the compression index. I'll go to the FE handbook, and the first thing I'll do is going to type compression index. And if you see, it's going to lead me straight to this page. This is under the civil engineering geotechnical part. So if you scroll down just 2 pages, our formula, it's right here. So the compression index, we are given two formulas. C sub C equals to delta E. Delta E is the change in void ratio divided by delta logarithm P. And delta P is the induced change in consolidation stress at the center of consolidating stratum. So we don't have delta E, but I'm noticing another formula here, which is related to liquid limit. And in my problem, I'm given a liquid limit of 45. So this is the formula I'm going to use. C sub C equals to 0.009 multiplied by liquid limit minus 10. Let's go ahead and write this down. C sub C compression index equals to 0.009 multiplied by the liquid limit minus 10. And this is going to be 0.009 multiplied by the 45 minus 10. And this is gonna be 45 minus 10 is 35, 0.009 multiply, and I am getting 0.315. 315. And C is our correct answer. As you can see, the only thing I did here, I just went to the FE handbook and typed compression index, what the problem is asking us, and I found a formula which is related to the liquid limit value given in the problem. And it was a quick problem to solve. Next, we're going to have the same problem. We are told that we are placing an additional 800 pounds per square feet. How much will the void ratio at the midpoint of the layer decrease due to the stress increase? Let's visualize our clay layer. I'm going to draw here a 3D. I'm going to try to do a 3D drawing here. And we have a load. Okay, we know that this initial load is of 2,000 pounds per square feet. This is the height. And we know we have saturated clay, so these are the clay particles. In between these particles is water. Next, we're going to have an additional load of 800 pounds placed on top of this clay layer. Okay, so now this is 2,800 pounds per square feet. So now what's happening, we're going to have a different age here. Let's call it age 1. And this is delta E. So increasing the effective stress on the soil causes a volume reduction as soil solids are pushed closer together and water is expelled from the pores. This process is called consolidation. So mainly what consolidation means is a reduction in the volume of water. Now, We know from previous problem, we have calculated the compression index, and we found that it is equal to 0.315. Now I would go back to the FE handbook and look, how can I calculate the change in void ratio? I'm noticing there is a formula which has a relation between the compression index, the void ratio, and delta logarithm P. Let's go ahead and write this formula down. C sub C equals to change in void ratio divided by the change in consolidation stress. And from this formula, we are going to calculate the change in void ratio equals to C sub C compression index multiplied by the change in consolidation stress, delta log base 10 P. So C sub C equals to 0.315. And now the change in consolidation stress, it's going to be equal to logarithm base 10 2800 minus logarithm base 10 2000. Using the properties of logarithm, this can be also written as 315 multiplied by logarithm base 10 of 2800 divided by 2000. This property is listed in the FE handbook under the mathematics. I encourage you to stop this video and use your calculator to find out the answer to get used to its functions. So I'll have 2800, 2000 divided, and then I'll do logarithm base 10 out of that. It's a property on the calculator, and then multiplied by 0.315. And I'm getting a value of 0.04603. So the change in void ratio is equal to 0.046. I'm going to get rid of these two, it's not necessary. So the correct answer is A. As always, if you found this video helpful, don't forget to subscribe and give it a like, because this helps put this video in front of more people just like you. If you have any questions, leave it in the comment section below. And I will see you next week.